Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of relations and functions. We are doing the examples of functions and in that particularly bijective functions. So let's look at the first question. So this is a function from natural numbers to natural numbers where f of x is defined as x minus 1 to the power x. Then f is, so you have got four options which is a combination of 1 onto, many one and into. So we will rewrite this function in a simplest way so that we can understand that. So you can rewrite this as see, we'll just separate it as even and odd, because when the power is even, minus 1 to the even power will be plus 1 and minus 1 to odd power will be minus 1. So that is very easy for us to separate it. So first let x be even. So if x is even, then this minus 1 to the even power will be plus 1. So hence it will be x minus 1. And if x is odd, so what will happen if the power is odd here? Then this will be minus 1. So minus of minus, you will have plus 1 here. Now let us decide whether this is 1 1 and is it onto. So just let us take some examples. The first example that we can take here, let us look at 0. So what will happen if f is 0? All right. So you will get minus 1, right? 0 minus 1. And if you have 1, that means if x is 1, so x is 1 is odd, therefore you put 1 there, 1 plus 1, it will be 2. And if you go on like this, let's put 2 here. Okay, so 2 is even, so 2 minus 1, so which will be 1. And then if you continue like this, let us say you take negatives. Okay, so again that is odd. So if you are putting any odd number there, so minus 1 and plus 1, you are getting 0 there. And then if you continue with the negatives and you put even number, so if x is even, then minus 2 and minus 1, so that would be minus 3. So do you see any repetition of the values here? You don't see any repetition. So every number will give you a unique output. All right. So these are the input values. So every input value will give a unique output. So there is no overlapping there. Therefore it is clearly 1 1, right? So that is 1 1. So we are left with only A or C. So these cannot be the answers. Now let us understand, do you have a unique pre-image? So let us just map this using arrow diagram. You have got all the real values here and the real natural numbers. So if you have the natural numbers, then you got 1, 2, 3 and so on, right? So 1 is mapped to 2 and 2 is mapped to 1, and similarly if you go for 3, what will be 3? So you have to use this formula, right? So it will be 4, and then if you are going for f of 4, 4 is even, therefore that is 4 minus 1, so 4 minus 1 is 3. So that is like 3 goes to 4 and 4 goes to 3, this continues. So you will have a same pattern repeating throughout. Okay, so every element in the second set here in the codomain has a pre-image. So do you find any element which is left out here? No, every element is related, therefore this is also onto. So that means this is both 1 1 as well as onto. So that is the first question. Let's quickly move on to the second question here. The second example is the function f from R to R. Now it is all real numbers. The first one was only natural numbers. See, f of x is equal to 6 to the power x plus 6 to the power mod x here is, okay, you have got these options. So, do you think that is 1 1 and on to? Let us see. Now, first of all, you have modulus function here, alright. So, that makes everything positive. Now, first of all, do you get unique output? Let us check it. So, let me take minus 1, alright. So, if you are taking minus 1 x to the power minus 1 plus, I mean 6 to the power minus 1 and 6 to the power a modulus of minus 1, which is 1, right. So, this is 6 raised to minus 1 plus 6 raised to 1, which is 6 itself, alright. So, that is 6 plus 1 by 6. See, this is 1 by 6. Okay, so that will be 6 point something, right. Then, what is f of 0? F of 0 is, say mod 0 is 0 itself. So, that is 1 plus 1, which is 2, and then f of 1, if you are having that. So, this is 6 to the power 1 and then 6 to the power 1 itself, that is 6 plus 6, you are getting 12. Now, the only point of conflict is minus 1 and plus 1 or minus 2 and plus 2. So, there is no chance that you will get same output. Okay. So, minus 1 goes to 6 plus 1 by 6 and then 1 goes to a different image. Both do not go to a single image. Okay. So, you do not have a situation of many 1, right. So, that is the only point we have to verify. You can go for other negatives and positives as well, you will get different images. So, every element has a unique image, therefore, it is clearly 1 1. So, once again these options are left out. Now, let us understand, is it onto or not. So, what do you mean by onto? Look at this, you have the domain of all real numbers and in the codomain also you have got all the real numbers. So, that means you have positives as well as negatives, you have rationals, irrationals. So, all those values are here. Just for example, I will take, see, these are not only the values, you have all the decimals here. Just for example, I have taken a few values. Now, the question is, if you put negative, are you getting negative here? Is the output negative? No. Even though the input is negative, the output is always positive because it is exponential function. Exponential functions are never negative. That means no value will have a negative image. Every value here will have a positive image. That means the negatives are not related to any of the pre-images, right. So, there is no element here which goes to negatives. That means this is clearly not onto, because there are some elements which are not related. What is the definition of onto? Every element in the codomain must be the image of some element in the domain, which is not satisfied here, hence it is not onto. So, only we are left with on, this is clearly 1 1 and not onto, therefore 1 1 and into function. So, that means option A. Well, so that is about the second problem and we have got the answer as option A. Let us move on to the third question. The third question is the function f from A to B defined by f of x is equal to 4x plus 7 where x belongs to the real numbers. See, these input values are all real numbers. So, this is a real valued function, alright. We do not know about B, we will see what is B there. That will be the range. Now, how do you prove that it is 1 1? Okay. So, how do you prove that it is 1 1? You have to take two elements. You have to take two elements in the domain. So, we will take two elements A and B, right. So, you take A and B belong to A. then consider that f of a is equal to f of b. So what you have to consider? Two images which are equal. Okay. So f of a is here, f of b is here. You think that they are equal, they are same. There is only one image. Okay. Now if a and b are also equal, a and b are also the same element, then one element has one image. Understand the contrary of it. Even though f of a and f of b are equal, you have one image. A and b, if they are different, then two elements are going to one single image or not. That means it will be many ones. So that's the logic behind this proof. So now what is f of a? Say f of x is 4x plus 7. Therefore f of a is 4a plus 7, and then f of b, so in place of x you have to substitute b, so that is 4b plus 7. Now clearly you can cancel out 7 on both sides. 4a is equal to 4b, hence a is equal to b. Now that's what tells us that this function is 1 1. We considered that the images are equal, and finally we proved that the elements are also equal. That means there is only one element and there is only one image. So there is no such situation that you have two elements going to one single image. So this is 1 1, hence f is 1 1. Right. So you have got that in the first option. Second option says it is many ones, so that cannot be the answer. Clearly option A is the answer. But let me clarify the options C and D here. The option C says that the function is odd. Now what do you mean by an odd function? First of all, you have the function f of x, and you need to consider f of minus x, and if f of minus x is equal to f of x, then it is even. And what about odd? If f of minus x is equal to minus of f of x, then f is odd. The simple examples are sin x and cos x. So if you put cos of minus x, it is cos x, hence cos x is even. Sin x, if you consider sin of minus x, is minus sin x, which is clearly odd. So keep those examples in your mind, you will remember even and odd clearly. Now let's understand this function, whether it is even or odd. So let us check. You have got f of x is equal to 4x plus 7. Now what you need to consider? F of minus x. So this is 4 into minus x plus 7. Now this is like minus 4x plus 7. If you take minus out, if at all you want to prove that this is odd, so you take minus common. So that would be 4x minus 7, but this is not equal to minus f of x, and this is neither equal to f of x, right? So this is not even and this is not odd also. So clearly they cannot be the answers. We have got the answer already, that's in the first option. So that is about the third question, okay, and it includes 1 1, many one, even and odd. So let's continue to solve these questions. Let's move on to the fourth question. Well, dear students, let's move to the fourth question from the relations and functions. Let f of x is equal to x square minus 4x minus 5, then f is it 1 1? If it is not 1 1, is it many one? Is it bijective, both 1 1 and onto? And fourth option you have got none of these, that is neither 1 1 nor onto. Now look at this function. This is clearly hyperbola, right? Parabola, I'm sorry. So this will cut the x axis in two places. So if you are going for the vertical test of 1 1, you will come across two values, right? So it is not 1 1, but how do you prove it? You can understand graphically, but if you need the proof, algebraic proof, then you can try this. See, you put f of 1, let us say. So if you put 1 here, then this is 1 square minus 4 into 1 minus 5, which is minus 9 plus 1, you get minus 8. And if you are going to put 3 here, okay, then this is like 3 square 9 minus 4 into 3 and minus 5. So that is 9 12 minus 5, which is 9 minus 12, you get minus 3 and minus 5. Once again you are getting minus 8, which tells us that if you have 1 and 3 here and minus 8 is here, so 1 will go to minus 8, 3 also will be mapped to minus 8. So that means it is many 1. So this example is enough to say that this is many 1 function and it is not 1 1, because you are getting 2 elements which are mapped to single element there. So this is just one example. You can take any other example, alright, any other example. You can take 2 and 4. Okay, so that is also one more example. So likewise you can generate many examples. Basically this is x1 is equal to 4 minus x2. So if this is 2, then you have to take 2 here. Okay, you then let us say you take 3, then 3 and 1. Okay, 3 and 1. If you are taking 5, that is minus 1 and minus 1 and 5. So that is also one more example. So all such examples you can generate. So this is clearly many 1 function, because if it is not 1 1, it cannot be bijective. Okay, so that is the option. 4th question. Now let's move on to the 5th one. In the 5th question, you have got a function where you have 1 plus n square, and this is defined on the set of natural numbers, and the codomain is also set of natural numbers. Hence it is very easy to understand, because you have the natural numbers and those are counting numbers. You can take the examples of 1, 2, 3, 4 and so on, and then the codomain is also the same set of natural numbers. Now let us begin with f of 1. So what is f of 1? Right, so f of n is given like 1 plus n square. So f of 1 is 1 plus 1 square, which is 2. And what is f of 2? The next natural number. Okay, so that is 1 plus 2 square, right? So that is 5. And similarly, if you are going on like this, this will be 10 and so on. So few examples are enough for us to understand the function. So 1 is mapped to 2, and then what about 2? So 2 is related to 5 and 3 is related to 10, and it goes on like that. Now is it 1 1? Is there any situation where for 2 different input values you are getting single output? So is there any situation like that? You don't have a situation like that, because every element will give you a unique output, correct? So because there is no question of putting negatives, because the domain is natural numbers, you don't have the negatives here. If at all you had the negatives, then if you had put f of minus 1, that also would give you 2. So then it would not be 1 1. But now, since the domain is natural numbers, for 2 elements you don't get a single image. Every element will give you a different image. Therefore this is clearly 1 1. And what about onto? Onto means for every element in the codomain must have a pre-image. Now what about 1? Does it have a pre-image? No. What about 3, 4, 6, 7, 8, 9? The next image is 10 here. Okay. So all these elements do not have a pre-image. No element is going to 3. No element is mapped to 1. So clearly there are many elements left out in the codomain, which means it is not onto, it is into function, this is not onto. So hence decide the appropriate option here. It is 1 1 but not onto. So this is 1 1 but not onto. Therefore option C is the right choice for us. So that's it for today's class. Thank you for watching. In the next class we will continue to solve questions of bijective functions. We are solving the examples of functions here. So let's move on to the sixth question. A function f from real numbers to real numbers given by f of x is equal to x cube minus 1 is 1 1 onto bijection, neither 1 1 nor onto are the options there. So let's find whether this is 1 1 or not first of all. So how do you say that it is 1 1? So we'll take two elements from the domain and let us consider f of a is equal to f of b. Then what is f of a? A cube minus 1 and f of b is b cube minus 1. So that is like a cube minus is equal to b cube, correct? Okay, so if a cube is equal to b cube, obviously a should be equal to b and hence this is 1 1. So what is 1 1? The function f is clearly 1 1. Now since it is 1 1, we have to check whether it is onto or not. So if it is onto, then it will be bijection, right? So otherwise you can go for the first option. Now let us check the onto property here. So do you think it is bijection? Now understand, you take any real number, okay. Let us use the normal methodology. We have to take f of x and then this is y plus 1. So what is x here? Cube root of y plus 1. It belongs to real number for any value of y. So x is defined for which values of y? For every value of y, x is defined here. Therefore, why? Because you can have negatives also. Cube root of negatives exist, correct? Okay. So what is cube root of minus 4? Cube root of minus 8? It is minus 2, because minus 2 whole cube is minus 8. Minus 2 into minus 2 into minus 2. So what is minus 8 to the power 1 by 3? So that is minus 2. So that means it is cube root of minus 8. So that is minus 2. It exists, right? So for negatives as well as positives, this quantity is defined. X is defined for any value of y. Therefore, it is onto. All right. So f is onto. Therefore, it is both 1 1 and onto. Hence, it is a bijection. Now let's go to the next question. Question number 7 here is also a similar problem. You have to find whether it is 1 1 onto or not 1 1. None of this. Okay. So let's go for onto first, because there are two options which are saying onto or not onto. Okay. So f of x 3 minus 4x is what you have, right? Now you take this as y 3 minus 4x. Now this is 4x 3 minus y. So x is equal to 3 minus y divided by 4. Now does it belong to R? X is in R. That means this quantity must be in R for any value of y. For any value of y, is this quantity defined? Yes, x is defined. All right. So you can put any value in place of y, you will get always x defined. That means you have f onto. So f is onto when it is not onto, if this quantity is not defined. For example, you have minus y here. Now when this is not defined, if y is 4, right, then this is not onto, because 4 does not have pre-image. All right, because if you put 4, no value will go to 4. something like that. Anyway, now since this is on 2, you get the first option. Well, so that is about 1 1 and on 2. And next, now let us understand the composite of a function.
Don't forget to like our video and subscribe our YouTube channel for all the updates.